get JTAG working on BeagleY-AI, the new board from Beagle Foundation. This board has no eMMC, so usually you boot up this board with SD card. JTAG connection is usually needed for low-level embedded developers who are trying to debug something that's happening on either the R5s, A53, etc. Most of the developers don't usually care about this. To get to the JTAG port, there are two ports available on this board. One of the port over here is called the PMIC debug, which is not where you have to connect. The one that we have to connect is the JTAG, the one labeled JTAG over here, and it is right between the two USB connectors that you have here, right here. Okay. Now this is very different from your standard JTAGs that you see elsewhere, which typically tends to be like pins sticking out of the board. Here you just have pads sticking out. Now to connect to this, you need what we call as a tag connect cable. It is an IDC cable. There's a link to that in the description. You also need an adapter because this is a 10-pin connector that comes out, and then that converts it into a 20-pin adapter. So this is how it looks like. On this adapter, one more thing that you have to be careful about is this TRST signal over here that's soldered out. You can buy this connector from Tag Connect, but this soldering is something you'll have to do manually. In addition, you need some sort of a JTAG adapter to connect your PC, which is how it actually does the debugging. For that, my preference is usually this little board over here. Is called TUMPA, Tampa. There are certain ways you have to connect your jumper settings. It's completely jumper based settings for this. Now the way that I've connected my jumpers, as you notice, is to get the JTAG to work. All right. Now most of this is fine. The hard part is actually connecting to the board. Now typically this board, this tag connect usually comes with a with a little holding thingy that looks like this, which you can plug in, and it kind of sticks around like this. Now the difficulty on this is there is no space. Since the board was designed to be around Raspberry Pi compatible, literally there is no space to put something like this in between. Also further, you'll notice if you look closer, there is a capacitor in the middle of the board. It's very hard to see on the camera, but there is little stuff over here which makes connecting even more harder. So to do that, so instead of using this standard adapter to keep the pins held up, you need this guy. This is a 3D printed image. Again, the link is on the description, which kind of replaces this and provides a profile for you to keep in, something like this. All right. So the 2-pin goes towards the edge of the board. If you look at it on the bottom, the 2-pin and a single pin over here. Okay, it's hard to see on this view, but they go like this. The 2 pins are towards the edge of the board, and the single pin is towards that side. Now this is a little bit tricky. Okay, so as we push, I hope you can see this properly, and narrow this up a little. Yeah, it's not. There we go. Have to use a little bit of force for it to actually stick around, and then you can see it all plug in. Okay, and that's it. This is held up here. Now you are ready to debug the board. Unfortunately, the board form factor is such that it sticks out like this, and then you connect this part to your Tampa board. Okay, now we're kind of plugged in like this over here, and then I connect my serial cable, which is connected to my PC, and then I have my mini USB cable that I connect over here, and I can see it starts lighting up all up. And then we have the power supply cable for the board that we connect over here. Now before I do that, I'll switch into the serial port um, screen view. Now that we have got the setups done, the next stage is to actually get OpenOCD building and running. OpenOCD build, there's a separate video in the instructions below, the description, which you can refer to for how to build OpenOCD, how to configure it, etc. And it's standard stuff, just the packages that you need varies a little bit. On my setup, OpenOCD is already built. However, what I'm doing is to create a config file which allows me to talk to the J721S2, also known as AM67A, which is the processor we are using on BeagleY-AI and Thumper. For that, you need a small config file. So I wrote a simple config file here which uses Thumper, and it says interface is equal to interface Thumper with JTAG. There are two config files that are involved: K3CFG, TI K3CFG, which has configuration for all K3 SoCs, and then another config file which is the Thumper config file, which is the actual interface to the SoC. The key thing to keep in mind is that before you include the K3CFG, say that the processor is J722S. That way it will know how to talk to the actual processor itself. In terms of the actual speed with FTDI, it's a 2-power configuration. I could not get anything higher than 20 MHz work on the board. Various reasons why. So the best I'm able to get with FTDI, which is what Thumper is all about, bit banging, is to get around 16 MHz debug speed. Okay. So with that, we can look at how actual debugging works. Okay, and to actually connect JTAG, it's a little bit of a sequencing problem here, and you have to be careful about what is connected how. The board by default, I have the SD card connected as we had seen before. The JTAG connector is connected, but notice something here. I have disconnected the cable from the Thumper board. Now there is some sort of debug to be done around that, but for the moment it is disconnected here. Now the way we switch this on is you can power this on, which is fine. We start up Minicom, which is a serial port over here, right? And we are going to intercept this at U-boot prompt. Now at U-boot prompt, it's easy to debug, but obviously you are trying to debug the bootloader itself, for example, in which case you would use a while one loop instead. Okay, now I'm going to interrupt the U-boot here. Okay, now we are in U-boot prompt and we have interrupted it. Thumper is also powered on at this stage, okay, but the JTAG is disconnected from the cable perspective. This is the only way you can actually get connection debugging to work, but at least on this board, which is normally not the case, but anyway. So you run OpenOCD -F, you see all the ports starting up here, which is perfect, and then you can actually run GDB as well at this stage. Okay, so you run the command gdb multi-arch -ex target extended 3334, which happens to be the port that I'm interested in. Notice as OpenOCD starts up, each of the port means something. The system controller is in port 333, R5, which is where our bootloader is. Initial bootloader was at 338, but since we are at U-boot shell, we are at 3334, which is the first A53 processor. Alright, so we're going to run that guy. I'll bring this straight in, and there we go. GDB is connected. I'm using GDB dashboard, which is why you see everything, stack trays, assembly, the entire shebang listed. But here you are, U-boot getting debugged. U-boot is paused at this stage. If you hit enter, nothing is going to happen. But if you go into GDB and let me resize this a little bit and say continue here, voila, we get the U-boot command. Moving on, print, working, Control C to break it, and nothing here. And if you say continue, A53 continues as you expect it to. Okay, and that is your GDB for you.